Hi, this is Kevin Trainer. Welcome to my lecture on non-functional requirements. This is part of my systems analysis course. And it's not a chapter that's in our textbook. And oddly enough, most academic oriented texts on systems analysis have completely dropped the ball on non-functional requirements. So there isn't a chapter in your typical book. And we're left to learn in more traditional ways. This is a section that I took from one of the training courses I teach in industry, and it was, I think, fairly highly influenced by the work of one or more of my colleagues, so I didn't invent this stuff. And it's, pretty well accepted stuff. So, even though it's not in the textbook. So what are non-functional requirements? Let's go explore that a bit. Okay. So, requirements are either something that a system has to be able to do, or some properties that the system has in order to meet the needs of the user in going about their job. Okay? And we typically divide them into two batches when we're talking in this kind of way. Functional requirements are the ones that we've been dealing with really all through the course. They describe the application behavior and information that the solution will manage. Okay, so what did we do to document functional requirements? Well, use cases were the primary way that we documented the functional requirements of a system, because each use case, it describes how the actor is going to interact with the system in order to get their job done, right? And implicit in that is, how does the system have to behave in this interaction, right? So these are behavioral. The other thing that we did, and we just did, when we came up with the data model, is we answered the question, well, what data has to be exchanged between the users and the system, and what data needs to be persisted by the system over time in order to support that application behavior. Okay? Still functional. So process-oriented requirements and data-oriented requirements are all functional requirements. So for the most part, the kind of requirements we've dealt with so far in the course are functional. So what are these non-functional ones? Well, they describe other properties that the system must have that are not application behavior itself, and also, although it doesn't say it here, are not a description of the data elements that the system has to persist or retain in order to support that application behavior. So, what are these like? Well, we have a memory aid that we use in industry. I don't know who dreamed this up, probably one of my teaching colleagues in industry, that said that all of the requirements can be remembered through a memory aid of an acronym called FURPS, F-U-R-P-S. So we either have functionality, which is, of course, the functional requirements, or ERPS. We have the F, or the ERPS, and the URPS stand for usability, reliability, performance, and supportability. And then I would say other considerations would go into non-functional requirements you could probably find a way to shoehorn them into the ERPS categories. But let's say that a client has a preference for a particular product, right? Okay, so we probably want to find some way to document that. Well, is that usability? Well, maybe. Is that reliability? Well, maybe. Probably what we want to do is we want to take that preference and say, look, instead of expressing the preference for the product, let's try to distill out what capabilities that product has that makes you like it. But there are times where you need to express some preferences, or perhaps even something as strong as a requirement that doesn't fit exactly into the ERPS category. And it's not really system behavior or data. So if it's not system behavior or data, you can make up another category apart from ERPS and use that as a way to document that either requirement or preference. Now, having said that, I want to emphasize that you need to distinguish, especially in this area, between requirements and preferences. Because I tell you how you're going to use this information, okay? You're going to use it when you go to decide how you're going to implement the requirements. What solution is going to be chosen to meet the requirements that you've identified? Is this going to be a system that you have to make yourselves? Are you going to develop it in-house? Can you buy it? Is it packaged commercial software? Is there an open source solution that you can adopt? Is there some kind of solution in the cloud that you can buy as a service? Now, the possibility that you can entertain a particular solution, of course, you can only entertain it if it meets the requirements. So the more requirements you identify, the less likely a particular solution is to meet the criteria. Well, how do you deal with that dilemma? Well, you deal with it, and especially in these non-functional requirement areas, you deal with it by taking the things that you would like to have, but don't absolutely have to have, and expressing them as a preference. So in the way that I'm going to teach you to document these, we're going to actually say if this is a preference. If it's only a preference, we're going to say we have a preference for such and such. We're not going to say this system shall do such and such. Okay? That's going to keep us from ruling out solutions that may be the one to get, but maybe they don't have every little thing we'd like them to have in our heart of hearts. But we can live without them because they're only a preference. Okay, so think about this a documenting of the non-functional requirements as the requirements, and if you have something that you don't want to restrict yourself too much on, try to ask yourself and your stakeholders, could this just be a preference? All right, let's go down to the first of the ERPS categories, usability. Okay, so again, we're trying to give you ideas here about what kind of things would not be system behavior or data that would fall into these categories. It's not an exhaustive list, but it's a good kind of checklist to go through. So human factors, aesthetics, consistency in the user interface, online and context sensitive help, wizards and agents, user documentation, training materials, Okay, so these are all things that are going to make the system more usable, and you may have requirements in these areas or preferences in these areas. Here's the place where you document it. Reliability. Okay. When we talk about the reliability of a system, we might be talking about the frequency and the severity of failure. How frequently can the system fail? And how failed can it be? Can it just be partially down? Does that have any value to us? So those are the kinds of things. Recoverability. Okay. How easy is it to get the system back up when it goes down? Some systems are very easy to get back up. Some systems are truly hard to get back up. Some system architectures have recoverability features built in. Things like database backups and transaction logging and things like that, and database recovery utility programs. They have this whole architecture. They have this whole infrastructure that's really geared to recoverability. All right, how important is that? Predictability. Most people like their system to be pretty predictable. They would like, for instance, to take a part of the system and run it once and get an answer, and run it again and get the same answer, and run it a third time and get the same answer, and not have there be some unpredictable aspect to it, where if you run it on a Sunday morning, you'll get one answer. If you run it on a Friday night, you'll get another answer. And it's kind of unpredictable. People don't like that. Accuracy, in the sense that we mean it here, is does it have to be accurate to the penny? Does it have to be accurate to a tenth of a cent? Okay. I've been just appalled in my professional life to find out that there are systems in major organizations in the U.S. where they can't balance the books, and they can't balance the books sometimes by hundreds of thousands of dollars. In fact, I have a former neighbor whose job it was to go into insurance companies. She was a data auditor in insurance, and she would go in and they would find all the lost money, right? So how accurate do your books have to be? I'm a big fan of have to balance to the penny. Other people are perhaps more forgiving. Performance. Okay. Users these days have pretty high expectations on system performance. Okay. And the one thing that they think are the most sensitive to is the last one on the list here, response time. Okay, typically by response time, we mean from the time that you press enter or return, or you click on a button, how quickly does it take the system to start to put output back on your page? Okay, now that's going to be different with different technologies. Certainly in a lot of web applications, we rewrite the whole page. So some of that, sometimes you're not only interested in when do you begin to see the new data, but when are you done, right? And typically people are talking about 1 second response time, 2 second response time, 3 second response time. The days where they're going to be willing to accept 10-second response time are long gone. Okay? So we have to be realistic about what the requirement is there. I guess I'm going to do these in reverse order. Throughput has to do with how much information you can get through the system in a given period of time. So it's not so much how long a single transaction takes, but how many users could be doing how many transactions over a certain period of time. So we might have a system that, with a single user, has very fast response time, say under a second. Okay, but if you took 1,000 users and you had to them try to do as many transactions as they could over an hour, you would just bring the system to its knees, right? Because you can't get a lot of throughput. All right, so that's another measure. It's typically how many users doing how many transactions over what span of time. Availability, what's the uptime of the system? When I got into IT, most corporate systems were up during the normal workday. So if it was some kind of online system, it would come up. Maybe if people came to work starting at 8 o'clock in the morning, it'd be up by 8 o'clock in the morning. And if people left at 5 o'clock at night, it would go down at 5 o'clock at night. We used to run the online systems on the same computers that we ran the batch overnight systems. And so the online systems would actually come down at the end of the day, and they wouldn't be available throughout the evening and the night. Well, those days are kind of gone because of the fact that people typically don't work in only one facility anymore. Okay, so I was working for an insurance company in the summer a couple of years ago, and somebody turned off our source code version control system at 3:30 our time because they thought it was already 5:30 our time, but we were in a different time zone. Okay, and they hadn't really thought, oh, gee, we've got people working in all time zones now. So we not only have people working in all time zones in say, the United States, but we have people working around the world. So the availability of a system, how much of the day and how many days it can be up, is a big issue. The efficiency, in a technical sense, the efficiency would have to do with, it has a real relation to response time and throughput. A system that's highly efficient would probably have quick response time. Okay, a system that was highly efficient might generate a lot of throughput. Okay, on the other hand, a system that was inefficient could maybe be speeded up or given more throughput capacity by throwing a lot of money at it. Okay, so you could maybe say, well, if we take the server that would ordinarily cost $10,000 and we spend $200,000 for it, we can get one big enough to give us the response time and the throughput that we want. But perhaps because of the inefficiency of the application, we would not want to spend that much to get the throughput and the response that we wanted. And speed is related to all these things. It's typically expressed as so many something or other per time period, right? So these are all interrelated, okay? But they're all, each of the words is getting us at a slightly different measurement. Okay, supportability. Okay, now something that system developers think about all the time is what is it going to take to support the system once it gets installed? Okay, now it's important for the systems analyst to be aware of this because it's really going to have an impact on the operating cost of the system over time and also its potential life. Okay? So a system that is easily configured and easily changed will probably have a longer life than one that isn't easily configured and easily changed. A system that is highly extensible in terms of, you can write more code to add additional features and add them seamlessly. Well, that's going to have a high value for people who want to do that. The one that isn't extensible could be quite fine for a customer who doesn't need those kinds of extensibility features. So this is the kind of stuff that we're talking about. A lot of times a phrase that you'll hear bandied about that relates to this is total cost of ownership. Okay? So what we might be looking at is we might be looking at some proposed solution that has maybe a very low acquisition cost, and yet because of its supportability being low, it might have a very high operations cost. Right? We might be working on it all the time and using up a lot of expensive people's time, or so that might be one scenario where there would be hidden costs in the support. The other could be we might be finding a product that is really tuned to the functional requirements that we have right now, but our functional requirements are pretty volatile and changing. And if this isn't a system that's going to allow us to change it and configure it over time, perhaps it's not going to suit us all that well in a very short period of time, like a year or 2 or 3. So this supportability area is something that we need to consider. So here are all the things that we lump into supportability. Testability. We're going to want to make sure that whatever code we're going to rely on has been tested. And ideally, we would like to be able to test it every time we make a change. So the kinds of things that we're looking at here with testability is the code in the system, does it come with a testing framework, with a test suite, so that you can test the application after you install it to make sure it's properly installed. Can you use that test suite and enhance it when you enhance or change the system such that you always have some kind of testing asset there? That has a pretty high value. Extensibility I talked about. Particularly if we're buying a software package, some kind of commercial off-the-shelf software package. If it's not going to meet all of our needs, then we're going to need to be able to extend it. And how seamlessly that happens can be pretty different from system to system. Adaptability. This largely has to do with if our requirements should change, how easy is it to reconfigure the system to account for that? Would we be able to change it by changing configurations? Would we have to change some source code? Is it possible that we just can't change it at all? Maintainability, the same kind of thing. Again, Maintainability, we get into issues like this. Um, is this a system that is created with tools that we know, okay, that we think are easy to maintain? For instance, there's a lot of intersection here. Is there a testing framework for it, right? All that kind of stuff. Compatibility. This is a lot of times you'll hear people say, well, you could use any solution as long as it's based upon an Oracle database, because we only use Oracle databases. Okay, well, that's a compatibility requirement. Or you might hear people say, we're a Java shop. Okay, so we prefer, it's not a requirement, but we prefer that if you're going to acquire a system that's already built, that it be based on the Java language. Well, that would be a preference related to compatibility. Configurability, there are systems in which they've been designed such that even the users can, by changing values in a table, change the behavior of the system fairly dramatically. So it's highly configurable. And there are systems where that can only be done by getting a programmer to do it for you. So if you have a pretty capable user group, maybe you would want some of these configurability features. Even if this was a thing that could only be configured by the technical folks, having them being able to do it by, say, changing some values in some files or databases rather than having to completely write new programs, well, that kind of configurability, even though it would require a technical work component, that might be preferable over one in which we had to do lots of programming, which might take more time. Serviceability. This is an interesting area, okay? Particularly when you have mechanical systems, okay? You have the issue of how often does it have to be serviced, and does everything have to stop in order for service to go on? We're all pretty used to the fact that when a car has to be serviced, that we're going to give it up for a day, okay? And a lot of car dealerships have loaners, and we're pretty happy with the serviceability of automobiles, okay? Now, can we have that same serviceability for our systems, right? If in order to service our system we have to give it up for a whole day, well, that might be okay if we don't use our system on weekends, all right? So that day might be a Saturday or a Sunday. Well, that's all right. But what if we have people who work all over the world? Well, we probably would get 24 hours in which all of our days off would overlap. So maybe we would have one day where we could do something. But so different systems are more easily serviced in terms of, does everything have to be down in order to service it? So those that are more flexible maybe would allow you to do some servicing with parts of the system up. Those that are inflexible would be, everything has to come down, and typically it has to come down for 48 hours. Well, that could be a real limitation for you. Installability. Okay, now, how much effort and how feasible is it to install this software solution and hardware solution in your organization? The differences could be dramatic, okay? For instance, let's say that we have some kind of application. We have one proposed solution where we could buy a web application, okay? And that web application could run on a web server, okay? And the client machines on which it could be accessed could be any personal computer with any personal computer operating system that had a modern browser. Okay? Well, then how hard would that be to install? Well, not too hard to install. We'd have to have the right kind of server. And we might have to go check if we had a couple of older browsers around, that kind of stuff. What if, instead of being a web application, what if we had created for us a desktop application, some custom software that could only run on the Microsoft Windows operating system? Well, a couple of problems there. One is we'd have to make sure that everybody had a Windows system. The other thing is we'd probably have to go install the software on every client machine. So the differences in the amount of work that it takes to install the initial release of your software or subsequent updates could be dramatic. So you really want to think about that. And localizability, also known as internationalization, has to do with where you're going to be using your system and accounting for the differences in language and notation for currency and dates and time and all those other kinds of things. Again, when I got into IT, we were building systems for perhaps one installation of a big corporation. Everybody, they not only were in the same time zone, they all worked at the same plant. Okay, so they all spoke the same language, we used the same currency, we all were in the same time zone. Not a lot of localizability issues. Okay, well now things are much more challenging in these kinds of requirements. I mean, even modest size organizations have people at a minimum spread throughout a country, so you've got time zone issues. Often it's spread throughout multiple countries, so you have in addition to time zone, you've got language and currency and all that kind of stuff. And the way we express dates is different, say, between Europe and the United States. So what are the requirements here? Where do you expect to run the system? Okay. You might not want to pay a lot for a system that is easily internationalized if you're only going to run it in Cleveland, Ohio. Okay, so that was the S of the FERP. So let's go back and look at all of the letters again. Okay, so the memory aid is FERPs: functionality, usability, reliability, performance, supportability. The F is for functionality. That's already documented, should be already documented in your systems analysis with use cases and a data model. Okay. Now what we want to do is we want to identify the rest of the requirements. Those we're going to do with ERPs: usability, reliability, performance, and supportability. So usability, again, here's the slide that summarizes that. And then reliability, we have a slide that summarizes that. Performance, slide that summarizes that. Supportability, got a slide that summarizes that. Now, here is a here's a potential pitfall that I'd like you to be able to avoid in your work. And primarily your work within my course, but your work when you get out to your day job as well. Okay. When are we going to document the non-functional requirements? Well, in my course, it's one of the last things that we do as part of systems analysis. Okay. So what usually happens is that people have already done their use cases. They've done their data model, and now they're working on this on the non-functional requirements, and they come up with a lot of ideas, and they write them all down in kind of outline form, as I will show you in a minute. And the mistake that they make is they put everything in there. They forget that some of the things they're going to think of in this phase are functional requirements. It's only human. It's only natural. Okay? We think about these things in an iterative kind of way. So what you don't want to do is think about a functional requirement here and say, forget about it. Okay. You also don't want to try to document it here where it doesn't really fit. Well, what do? Well, you put it on a list while you're working on these non-functional requirements, and then you go back and you make some changes to your functional requirements, right? So what would happen? Well, you might have to go to a use case specification, and you might have to add another alternative flow. Okay, you may discover a whole other use case. You may discover some data requirement that will cause you to tweak your data model. Something that people get kind of suckered into all the time is when they're thinking about supportability, they'll think about something like security, which I think it does have some non-functional requirements, but it has a lot of really functional ones that we typically express in the use cases as administrative use cases. The two that I typically say that you're always going to want are authorize user and log in. Okay, so somebody will think of some aspect of how the security for the system has to work. Okay, and they'll go and they'll say, oh, well, I'll just slap it into non-functional requirements. Well, is it just part of the use case specification for login or authorize user? Probably. Okay, so this is just because we're doing this last doesn't mean that every idea that comes into your head goes here. Some go here, some go back as enhancements to the functional requirements. So how do we document non-functional requirements? Well, typically we write declarative sentences where we say the system shall something or other. Okay, the system shall support up to 100 simultaneous customer users. Okay, the system shall fail no more frequently than once per 30 days. The system shall be recoverable in 2 hours or less. All right, so those kind of sentences are the way that we typically express non-functional requirements. Now, if you've only thought of a short list, I'll say 10 or fewer, you can just create a little list. I originally used to tell people to bullet them. Okay, kind of like we have on the slide here. It's probably better to number them because in a couple of minutes I'm going to tell you that it helps to number them because you might want to refer to one of the requirements from the other, and it would be good to be able to refer to that number. Okay, so even if you have 10 or fewer, I think you could have a list of 10 numbered non-functional requirements. More than likely, you're going to have 11 or more, in which case, express them as an outline, right? You know, a numbered outline. So, you know, and you can use the numbering system that comes from your word processor, okay? Any reasonable kind of a combination of letters, numbers, Roman numerals, etc., in which you make up some kind of outline will work. And then hanging along the bottom of those are the same kind of declarative sentences that say the system shall X, the system shall Y. Okay, so it's not too hard. Now, that's my last slide. How about that? Now, I do want to say one more thing, and that is how, well, whenever I say I want to do one thing, I want to say two, so I'm not going to number them, I'm just going to say them, right? One thing that is not cool is to come up with a list, an outline, in which you repeat yourself, okay? Well, how could that happen? Well, one particular requirement could fit under, you know, two of the ERPS categories, right? Or they may relate to each other. They may have, you know, be interlocking, overlapping. What I usually say is the best practice, and this is what I want you to practice, is don't repeat yourself, okay? The first time you find that you have a requirement that applies to some part of the outline that you're doing, well, then document it there. And it's going to have some kind of number in the outline, okay? If later on in the outline you think the same thing applies, just say C requirement 1.A.43, or you know, whatever your outline system is, okay? If in fact you want people to think about that requirement in more than one place, only write it down in one place and refer the reader back to, typically refer backs are better, but you can do refer forward if you want to, if you think the more natural place is forward. But only document a requirement one time. Why is that? Well, redundant information is hard to maintain. As soon as you take the same requirement and express it in more than one place, you raise the possibility, if once you're reviewing the requirements with the stakeholders and they go, oh, Kevin, you got that almost right. No, I want that a little bit wrong. You go, okay, I'll change that. You forget all the places where you have to change it. So just put it in one spot, then refer to it as many times as you need. And then the other thing is, as I mentioned before, but it's the kind of thing that bears re-mentioning, is if you have a preference, you have a preference for a product, you have a preference for a programming language, you have a preference for something that follows a particular standard, but it's not a deal killer, okay? Then express it as a preference. Instead of saying the system shall, you can say a system that blah, 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 blah is preferred, or there is a preference for blah, 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 blah. Instead of saying the system shall, which is a requirement, it's imperative, you're saying prefer. Okay, you can still express that desire, but what you'd hate to do is to go out and look at the potential solutions and have a really good one and then have someone say, well, no, I've got 4 requirements that it doesn't meet. And then you go, oh, we really weren't serious about them. Weren't serious about them? Why did you put them down? So expressing a preference is a way to hedge your bets and to allow more potential solutions to be considered without giving up the expression of what you think the ideal solution would have. It would have all the requirements plus all the preferences. Okay? Now, what we typically do is we go out and we look at the different alternatives and then we measure them up. Okay? And we might look at 2 possible solutions and we might say, well, they both meet all the requirements. One of them also meets all the preferences. And of course, the decision makers are going to say, well, how do they compare on, say, cost? And you might say, well, the one that meets the preferences says costs $100,000 more. And they might say, well, tough luck, we're not getting it. Okay? Or it could be saying, well, it costs $5,000 more on a bill of that's already $1.2 million, and they go, well, that's not really material. Let's get the one. Let's spend the $5,000 and get all those extra things that we wanted. Okay, but they get the alternative because you haven't ruled out the lesser system because you've expressed the preferences as preferences instead of requirements when they're not deal killers. Okay, so I have a tutorial for this in which I go through this for a system, and associated with the tutorial is a document template from Microsoft Word. It's actually an outline that I've built from the categories that I showed you in the slides, the ERPS categories. And it gives you, I think, a pretty good idea about how I go about doing it. And these are the practices I would like you to follow. So without further ado, I'm going to encourage you to go on to the tutorial, and I'm going to say bye until next time. Bye-bye.